Welcome to the Crazy Head Chemist. So another video by the Crazy Head Chemist. Bam! So today we're talking about isoelectric ions. I want you to think about isoelectric and think about what that might mean to you. So isoelectric ions are ions with the same number of electrons. That is, iso is the prefix for the same. However, they have different Z. That is the atomic number. So the number of protons or that positive charge in the nucleus is different. Okay, all right, so this is an application of Coulomb's law. There are so many different uses of Coulomb's law in chemistry. So I'm going to point some of these out here. So the ions are oxide ion going from the left to the right, oxide ion, fluoride ion, sodium ion, magnesium ion. You should see that I got two nonmetals and I got two metals. Number of electrons is 10, 10, 10, and 10. That is, the number of electrons, because they are isoelectric, are the same. That makes sense. The number of protons, however, differs. Okay, the number of protons is increasing by 1 each time. Okay, so hopefully that makes sense. And now look at their radius in size, their picometers. This is very important. Notice that I'm going to go to the left. I'm going to go on the left-hand side with the oxide ion and look at oxide. It has a 140 picometer size for the oxide ion. Notice that the number of protons is 8 and the number of electrons is 10. So there are fewer protons than there are electrons. So it's very difficult for those 8 protons to hold on to those 10 electrons. So therefore the oxide ion is getting larger. Now, as you move one column to the right with the fluoride ion, you have increased the number of protons in the center. Therefore, you should be able to bring in some of those electrons and get a little bit smaller. Notice that the size in picometers has gone from 140 to 133 now. Okay, now as you move over and increase in one more proton in the nucleus, now I have 11 protons for sodium ion and 10 electrons for the sodium ion. Now I have 11 protons. Now I actually have more protons than I have electrons. Okay, so now I'm going to draw in those electrons that are on the outside from those protons much tighter, and notice there's a huge size difference there. Again, this is kind of looking at nonmetals and metals as well, but this is now 98 picometers. Now we're going to move one column over to the right and look at magnesium ion. Now magnesium ion has the same 10 electrons that all of them do. However, it has 12 protons in the nucleus, so it's going to draw those electrons even tighter because its effective nuclear charge is the greatest of all of these. And that's why its picometer size is 79 picometers. Now, if I were to add one more, if there was an element with a 3+ charge that had those on there with the 10 electrons, then you could, like aluminum ion would be smaller still. I guarantee you it's smaller than 79 picometers. So, something to take away here. If you look on the left-hand side with the nonmetals, okay, if you are looking at isoelectric and they must have the same number of electrons, the one with the greatest negative charge is the largest in size. You look far to the right. If you look at isoelectric ions, the cation with the greatest positive charge is always the smallest. Okay, so I've highlighted each one of these 4 here. They are all isoelectric. They all have the same number of electrons. That's critical. It's where the protons, the effective nuclear charge, has changed, and that allows us to predict their sizes. Even if you don't know their sizes in picometers, you should be able to organize these according to their size. Okay? Before I carry on too much, I got a little bit of elemental humor here, and I'll just wear my hat right now. This is a garlic clove. Hope you like that. I'm going to have some garlic tonight and some pasta. That sounds delicious. So here's some elemental humor for you. What do you do when you find a dead chemist? Oh, it's elemental humor, so you bury him, of course. All right. What is the purpose of a doctor? It is to helium or cure him. Of course. So, if you can't helium or cure him, then you bury him. Ha! Elemental humor. Okay, what do you call a convict who dresses up like a clown? I don't have a clown suit. I hate clowns. They scare me. Well, they're a silicon. Ha ha! Anyways, I hope you enjoyed that. Give me a thumbs up if you liked that video. Hopefully you learned something. Give me a thumbs up. Subscribe to my YouTube channel. And I'm going to see you next time for more cool chemistry videos. Bye now.